So today we are going to find the maximum subarray sum. So today we are going to discuss the better solution. So I'll say the better solution, and later that we'll see. Sorry. So today we're going to discuss the brute force solution first. First we'll start from the brute force solution. Later we'll get to the better, and then we'll go to the optimal. So when I say maximum subarray, what is the subarray exactly? What is subarray? We know subarray, the contiguous part of the element. What is a subarray? Contiguous part of the subarray, part of the array. The contiguous part of the array is known as subarray. So what is this contiguous part of the array? So this element 2 is a subarray. I can say element 2 is a subarray. I can say this 2 minus comma minus 3 minus comma 4 is a subarray. It is a contiguous part and it is a subarray. And I can't say this both as subarray because this is minus 1. Because this, I can't say these both as subarray because this is minus 1, this is 1, this is 5. This is not contiguous part of the array. This is subsequence array. What is this? This is a subsequence array. So I can't say this is a subarray. I can't say this is a contiguous, but I can say this is a subsequence of the array. Right. So okay, let us try to understand the brute force solution. So what I'm going to do here is I'll say this is the first element and this is the second one. This is the first. This is my first 2 minus 2 is my first subarray. This is my second subarray. This is my third subarray. This is my fourth subarray. This is my fifth, sixth, seventh, and eighth. So this is how what I'm going to do here is I'll take a pointer here. I'll take an I pointer and I take a J pointer. So I pointer, I'll start from this and I go to up and I go every specific element and I return the summation. And I say summation is 2 here, first element, then I go here, then minus 2 minus 3 is my subarray, then the summation here is minus 5, then I go here, then the summation minus 2 minus 3 4, then the summation will become this is how I'm going to add this summation. This is how I'm going to do this. When I get the greatest subarray which gives my answer, here is my answer is 7, right? I forget to mention this. See, greatest subarray here, when I get the greatest summation, so that's going to be my answer. For suppose we can say this. So this is going to return me the answer 7. So this is the maximum subarray. This is my maximum subarray. Just try to code this thing, then we'll get to understand. Then you guys can get understand more betterly. Can I say? So what I'm going to do here is I'll take a loop. I say I equals 0, I is less than n, and I'll increment. And I say, and I take another loop, j equal to 1, j equal to I, because I was also starting from here, because I should need to also get the subarray for this minus 2 also as well, right? So I'll start from here. Then I say up to j to n, and I go until j to n, and j will increment. Then I say I'll take a summation is equals to 0. I take a summation is equals to 0, and I take a loop k which will run up to I to j and give my summation of array of k of the array. So I'm going to iterate the array. So here I've got the summation for this. This is an internal loop. So this is going to give me the summation of every subarray. This is going to give me the summation of every subarray. Okay, right. And then I say summation of every subarray, then I get the maximum. Then I say max of summation comma maxi. Summation of maxi. So this is how it's going to work. So this is my internal loop, and my internal loop will give me the uh, every subarray generation will be happen here. Here every subarray generation will happen here in this internal loop. Every subarray generation will happen here in this internal loop. Once it's okay. So what I do here is I'll initialize maxi as integer of minimum. Why integer of minimum? So I need to get the maximum. I need to get the maximum as the lowest. So what I'm saying here is the maximum is going to store the integers. I say integers, and it will be storing, maximum is storing the lowest possible values. So it is going to store the lowest possible values. So this is going to store my lowest possible values. Lowest possible values. It is going to return my lowest possible values. So for that I was using this. This is really important. So maxi integer underscore min. So this is going to give me the lowest possible values and of integers. Okay, let's try to get the time complexity. So the time complexity here is, since we are running 3 loops, then the time complexity will become n cube, and time complexity will be nearly will become n cube. Why I'm saying nearly, it become near about n cube? Because why it's giving me, because n cube, because whenever here j is whenever here I whenever here I is iterating, whenever I is using, whenever I was using the I, and I was going up to, I'm not going, when I was at the I, i'm not going I'm not going. I know i know one thing. I was running I was running from I know this loop is running. This loop is running from I, and it will go up to. It won't all the time go up to n. It won't all the time go to up to n. That's why I say the time complexity is near about n cube. Near about n cube because j I is not all the time, when I is running, and the n doesn't won't go all the time to the array, n doesn't run for n times or n times in the array. For that the time complexity will be big O of nearly big O of n cube, and the space complexity will be big O of 1. So okay, now we are just, okay, what happens here is we're going to find the better solution. Now we're going to find the better solution. I say better solution. Yeah, better solution. What I'll say here is I'll quickly erase this thing. Yeah. Yes. I just need to optimize this n cube, right? In the better solution, we're just going to optimize this n cube. It's nearly about big of n cube, and in the better solution, optimal solution in the brute force solution. So we're going to optimize this in the better solution. So this is the better solution. So what I'm going to do here is, I know one thing. So what we're doing here is, we when I was here at second element, I'll add second element, then third element, then this both subarray will give me the sum of minus 5, right? Then again I'm going to add this, then again I'm going to add this, then again I'm going to add this, again. That's how I get the maximum subarray. We all knew this. We all knew this. I say, and the first time I do minus 2, and I said the first element the minus 2, and the summation is minus 2. And the second element, when I have first subarray, my summation is minus 2. For the second subarray, the summation, then the summation is minus 5. And the next minus, for the next subarray, my summation is 1. Summation is 1. So okay, this is what we have done in the previous at brute force solution. To optimize this, I'm going to remove this. This extra loop, and I say, and what I say here is, so this is, so whatever the summation of my previous array, I'm going to add that with the next element. Then I get my summation. So this is how I'm going to do this. Whatever the summation of my previous element, of my previous subarray, then I'll add to the next element. Then I get my summation. So this is how I'm going to do this. Minus 2 plus minus 2 plus minus 3 plus 4, that is going to be my 1, right? So what I was doing here is, this is my previous subarray, and I'm going to add this with the new element. Then I get my summation, and I know, and I no need to add this again, minus 2, minus 3, 4, and I won't need to do this again and again, right? For that we are just using this. For that we're using this, and I say here, I say summation. I'll put the summation here, initialize the summation here as 0. And what I say here is, hey summation, when you are iterating the array, add up array of j. Hey summation, when you are just iterating the array, add up array of j and give me the maximum element, and give the maximum element. So this is how we're going to optimize in the better solution. We're going to optimize the time complexity. Now the time complexity will become O of n square, right? The time complexity here will become O of n square. So okay, sorry, the time complexity is equal of n cube. It's big O of n cube, not near effort. It's big O of n cube, and the space complexity is big O of 1. So today, so now we are going to find the optimal solution for maximum subarray sum. So for this, I'm going to use Cadence algorithm. So we're going to find this using Cadence algorithm. So what is Cadence algorithm states? Okay, it states that, okay, we'll do, we say maximum is, write it in a proper way. We say maximum is equals to, here the maximum is the maximum element is initialized with the lowest possible value. So the maximum element is initialized with the lowest possible value. So then I take summation is initially initialized with 0. uh, i'll I'll go here. This is my first element, minus 2, and I initialize summation as minus 2. Okay, minus 2. And what I do here is i'll just I'll just update the maximum to minus 2, because this is minus 2 is greater than the lowest possible value, right? So for that, I'll update this. Then it will be like minus 2. Then it is minus 2. I'll erase this. Then it will be good. Minus 2, right? Okay. Then I move. This is minus 3. This is minus 3. So we should need to remember one thing. Before moving, the summation is less than 0. If it's less than 0, because minus 2 is less than 0, then initialize summation as 0. Then initialize summation as 0. I say 0. Summation is 0. Then when I move to the other element, this is minus 3. So I don't take I say summation is minus 3. Now the summation is minus 3, but I won't take it as a maximum, because minus 2 is greater than minus 3. Just remember, minus 2 is greater than minus 3, because it's like, right, 0, minus 1, minus 2, minus 3. If we take this, 0 is the greater, minus 1 is the greater, minus 2, later that minus 2 is the greater. Minus 3 is the lowest, then minus 2. We should need to remember this. This is an important one. When I move, before I moving, I'll initialize it to 0, because summation is less than 0. Then initialize with 0. Then I move. Then now my summation is 4. Now my summation is 4. Then I'll update my summation to then I'll update my summation to maximum. Then it will be 4. Then now my maximum is 4. Now my maximum is 4. I'll erase it, and I say now my maximum is updated to 4, because minus 2, because 4 is greater than minus 2, right? Okay. Then I'll move. Then I move minus 1. 4 minus 1 is 3. Then my summation is 3. Then I move minus 2. Then my summation is 1. Then I move. Then I'll move, and I'll increase my summation to 2. Then I move. My summation will become 7. So what is the advantage of taking these all negatives? Let's try to understand. Here to here, my summation is plus 2, right? My summation is plus 2. And this is 5. When we add up minus 2 plus 2 with the summation, then I get the maximum answer as 7, right? I get the maximum answer as 7. For that, we use these negatives also. We use the advantage of these negatives, right? Okay. So this is how it works. And we have got the maximum answer as maximum summation answer, that is 7. And when we got the maximum subarray, that is 4. Maximum subarray sum, that is 4. Right? Then I move and I say minus 3. Then it'll be like 4. Okay, the iteration has over, and we have got this highest one. Yes, right. Here the Karen's algorithm states that Karen's algorithm states that Karen's algorithm, Karen's algo states that, hey, I don't care, I don't care, I don't care, I'll take anything, I'll take anything, but but if but if it is summation, but if it but if it is below zero, then I'll drop it, then I'll drop it, then I'll drop it because it doesn't have any significance, because it does not have any significance, because it does not have any significance, right? Okay, this was good, but what if we have given an array and it contains -4, -3, -2, -1? What if it contains all of these negative elements? Negative elements, right? So if I have given an array which contains all minus negative elements, here the maximum subarray will be like this. Here the maximum summation is -1, right? This is the maximum summation, and we have clearly, here it has clearly stated that you should need to give the element which is greater than 0 or equal to 0, right? Here we have stated this. If it doesn't, if the array does not have an element which is greater than 0 or equal to 0, then we should need to return the empty subarray. So this is empty subarray. This is how we represent this. This is a empty subarray. We should need to return this empty subarray. How we can return this? If I say if the maximum is less than 0, then I say initialize maximum as 0. So because this is my empty subarray, because this is my empty subarray. Just remember this. This is more important for the interviews. Yes. So let us try to discuss what if. So what if the interviewer asks you? So what if the interviewer asks you to code this maximum subarray? How you're going to do this? Maximum subarray sum. Yes. Maximum subarray sum. How you're going to code this thing? I say here my maximum. Here my maximum is initialized the lowest value, lowest possible value, right? It is initially initialized with the lowest possible value, and I say summation is 0. Then I'll write a loop I0 n, and I'll go to till n, and I'll increment. Then then what I'm going to do here is I'll say I'll say if summation I'll say if summation is greater than maximum, then I say if summation is greater than if the summation is greater than the maximum, then my maximum is my summation. Then my maximum is summation. Then what I'll do? I'll also say if summation is less than 0, then summation summation is to be 0. Then I'll write another condition, that is if maximum is less than 0, then I say maximum is 0. Why? We are writing this for the empty subarray. If the subarray contains all the negative elements, then we say it is an empty subarray. right? For that we're using this. We have discussed previously that. And now what I'm going to do here is, what if the summation is equal to 0? What if the summation is equal to 0? Here what we have, I'll say, here up to here we have uh, the summation 0. For this subarray the summation is 0, and it's go on for this minus 2 subarray the summation is here we have got 0 summation, and for this minus 3 subarray we have got the summation here is 0, right? And it's go on here the summation we have got 0, and it's going on and it's go on, right? And it's go on. For that I'll say, if the summation is equal to 0, I'll say i start I. I'll take two new variables, that is answer start, and I take answer end. Answer start will be initialized with -1, and this is also initialized with -1. Okay, right, done. So what I say here is, if the summation is equal to 0, then start from I. What does that mean? So as we have seen here, this is 4, this is -2 comma -3 comma 4. I remember this. Here we have the array -2 comma -3 comma -4. So we knew this. This is initially 0. This is 0. This subarray we've got the summation 0. This for this subarray we've got the summation 0, and it's going on 0, right? And it's going on 0. For that I say, if I was starting from this, I initialize this as start. I'll initialize this as start, and I say here, I'll say whenever the summation exceeds, answer start will be start. Okay. Whenever the summation exceeds, the answer start will be start. Right. Okay. Answer start will be start, that is initialized. Right. Okay, I say, if you're standing at I, and you got the maximum summation, can I say the current indexing, the current end index will be I? Can I say this? Yes, I can say this. So I'll say here, answer end is equals to I. Why? Because I've told you this. If I was standing at the current index I, and if my summation, and I've got this, and I've got sum it up, and maximum, and I got the summation maximum summation, then I'll be currently at the end index I. Then I'll be currently at the end index I. For that I have put this answer end is equals to I. So this is how you should need to explain the interviewer if he tells you to code the maximum subarray. So this is really important. Remember this. So okay. So this is the optimal solution for the maximum subarray. We should need to remember this. Yes, right.